Ladies and gentlemen, notes 5.3 are on solving systems of equations using substitution. This is our second day of notes. We did our first day in class. The second day we are doing through this video. Where it says solve the following system of equations, don't do that right now. We will do that sometime in class in the near future. So if you can just scroll down, or actually look down, you don't need to scroll down, at the list of steps to solve a system of equations by substitution, you have your example right here. We're going to be using this example so you can follow along and understand what the list of steps are. If you forget how to solve, you just need to come back and look at this list of steps and you should be good to go. Okay, so the equation that we're going to solve is 3x minus 2y equals 11 and x plus 2y equals 9. So let's look at the steps that we have in order to solve this problem. Step 1 is to isolate a variable in one equation. Look for the easiest variable to isolate. So we actually have 4 choices of variables. We can either isolate this x, we can isolate this y, we can isolate this x right here, or we can isolate this y right here. It's 100% up to you, but don't make your life difficult. So do you see this x right here, the first one that we have right here? In order to isolate that x, we're going to eventually have to divide by 3. And 2 and 11 are not divisible by 3, so you're going to have to deal with fractions. If you can avoid it, okay? Same thing with this 2y. Eventually, you're going to have to divide by either 2 or negative 2, depending on what side you get the 2y on. Regardless, 3 and 11 are not divisible by 2, so again, you're going to have to deal with fractions. Sometimes you'll have to deal with fractions, but if you can avoid it, avoid it. See this x right here? It has a coefficient of 1. Everything is divisible by 1, so that's going to be the easiest variable to isolate. So what I'm going to do is I'm going to color code my equations so you can see what I'm talking about. I'm going to color code the top one blue, and the bottom one I'm going to color code it red. So x plus 2y equals 9. In order to isolate the y, I'm just going to subtract 2y from both sides. So I get x equals 9 minus 2y. Okay? Now, the reason why this method is called substitution is because you are going to substitute that into the other equation. So make sure that when you take this and you plug it into the other equation, not the one you isolated the x in, because if you plug it back into the one that you isolated x in, you'll end up getting 0 equals 0, which really isn't very helpful to you, okay? So let's go ahead and plug it in. So 3x minus 2y equals 11. So then every time I see an x, I'm going to replace it with all of this stuff right here, because this is what x is actually equal to. So I'm not changing it, I'm just writing it with something different. So x is equal to 9 minus 2y, so I'm going to replace the x with 9 minus 2y. And then I'm going to copy the rest of the equation down. So minus 2y equals 11, okay? Now, if you notice, this equation had 2 variables. This equation only has 1 variable. Now it's so easy to solve. You know how to solve equations with just 1 variable in it. So let's go ahead and solve this equation. So step 3. Now that you only have 1 variable in the equation, solve it. So I'm going to distribute the 3 through. So I end up getting 27 minus 6y minus 2y equals 11. Okay? So then I get 27. Combine your like terms, you get negative 8y equals 11. Subtract the 27 from both sides, you get negative 8y equals negative 16, which means that y equals 2 when you divide both sides by negative 8. Okay, now that I know what y is, and I actually have an actual number for y, I can take that number, this 2, and plug it into either equation that I want. The top equation, the blue one that we have up here, or the red one, the bottom equation. Totally up to you. I'm going to plug it into the bottom one only because it looks simpler, and I don't want to have to worry about making any mistakes. So every time I see a y, I'm going to replace it with a 2. And that's equal to, sorry, this is my red equation, that's equal to 9, right? So I get x plus 2y equals 9. Go ahead and solve it. X plus 4 equals 9. X equals 5. So then that means that my answer is 5, 2. So it says to write your answer as a coordinate. So my answer right here that I get is 5, 2. which is where my two graphs would intersect if I were to graph them out, just like we learned in our last video. Last thing I need to do is check the solution in both equations. So I'll go ahead and do that. I'm going to split this down the middle so that I can check the equation twice, especially since there's two equations, right? So the first equation was 3x minus 2y equals 11. So I'm going to go ahead and write that down. 3x minus 2y equals 11, but instead of x, I'm going to replace it with 5, and instead of y, I'm going to replace it with 2, okay? So I'm going to replace this guy right here with a 2. Then I'm just going to go ahead and evaluate. So I get 15 minus 4 equals 11, and then 11 equals 11. So I know that I'm good with one equation, so I'm only 50% sure that my answer is right. Now I got to check it in my other equation. So x plus 2y equals 9. Okay, so every time I see an x, I'm going to replace it with 5. Every time I see a y, I'm going to replace it with a 2. So right here, this is going to be a 2, and this is going to be a 5. So then when I add it all together, I get 5 plus 4 equals 9, 9 equals 9, and now I am good to go. All right,